All right, guys, in Unit 15, we're going to be talking about ratios, rates, and proportions. So Unit 15, Part 1 is all about ratios and rates. So let's start with the definition. The definition of a ratio is that it uses division to compare two quantities. So we're going to compare two quantities with division. If you look at this little section that says writing ratios right here, this is just copied and pasted out of your book. It says you can write the ratio of two quantities A and B where B is not equal to 0 in three ways. So you can write ratios in three ways. The first way is to write the word to. The second way is to use a colon. And the third way is to actually write it as a fraction. And we know the fraction way works because we know that a fraction represents division. So let's look at an example. It says, Sam shot 50 free throws. He made 35 of the free throws. Write the ratio of makes to misses in simplest form. So we need to make sure we underline that. We're going makes to misses. So it says that he made 35 out of 50. So he made 35, and that means that he missed 15. So I can write that 35 to 15. And that's the first way I'm going to write it. Now my directions say to write the ratio in simplest form, then write the ratio in three ways. So we simplify ratios just like we simplify fractions. 35 and 15 can both be divided by 5. So I can write this as 7 to 3. So that's my ratio in simplest form. Then I need to write the ratio three ways. So there's my first way with the word to. My second way I can use a colon. The third way I can write it as a fraction. So that's three different ways in the simplest form. Makes to misses. Next definition we have is equivalent ratios. Ratios are equivalent when they have the same value. So two or more ratios with the same value are equivalent ratios. So go to the next section. It says to order the ratios from least to greatest. So just like when we've ordered anything, we need to put these in simplest form. So what I'm going to do is I'm going to turn all of these, since it's going to be hard to reduce them, I'm actually going to turn them all into decimals. That means I'm going to divide the first number divided by the second number to make them all decimals. So I would do 6 divided by 3 and get 2. When I do 13 divided by 4, I get 3.25. When I do 19 divided by 2, I get 9.5. 15 divided by 10 is 1.5. And 8 divided by 2 is 4. So I turn those all into decimals, or I divided them all out. Now I can put them in order from least to greatest. So I know that 1.5 is going to be my least one. Then I'm going to have 2. Then I'm going to have 3.25. Then I'm going to have 4. And then I'm going to have 9.5. So when I write them in order from least to greatest, I want to write their originals. So 1.5 was the least one, and the original was 15 to 10. Then I have 2, which was 6 to 3. Then I have 3.2, which was 13 to 4. Then I have 4, which was 8 to 2. And then the greatest one I have is 9.5, which was 19 to 2. So those are in order from least to greatest. I'll leave number 2 for you guys to do on your own. All right, a couple definitions to the bottom. So we talked about a ratio at the beginning as using division to compare two quantities. A rate is a specific type of ratio. A rate is a ratio of two quantities measured in different units. So think like miles per gallon or feet per minute or something like that. That's a rate. So ratio of two quantities measured in different units. And then a unit rate is a rate that has a denominator of 1 when written in fraction form. All right, so if you go ahead and flip over to the back, it says find the unit rate. So remember, we want the denominator to be 1 to turn these into unit rates. So first off, just recognize that these are rates because they have two different units. So number 1 has people and cars, so that makes it a rate because there are two different units. So we have 24 people over 6 cars. So So I have 24 over 6. I want to make the denominator 1. So to do that, I'm going to divide by 6, because 6 divided by 6 is 1. So if I do it to the bottom, I also have to do it to the top. So that's 4 people, so 1 car. So now I have a unit rate, because my denominator is 1. Right? I could also just say that 4 people per car if I want to. So number 2, I'll leave for you guys. In the next section, we're going to look at writing equivalent rates. So I'm going to show you a very specific way to do this. This is one of those times where I want you to do it exactly how I show you, because I don't want you to, it'll seem really basic at the beginning, but when we get on to harder rates, you're going to want to do it the way that I show you. Okay? So our first problem says 12 kilometers to 1 hour is equal to how many meters per 1 hour? Again, I know that you can probably figure this out pretty quickly, but please use the method that I showed you. So first thing we're going to do is we're going to rewrite that first one where we have both units of measurement in there. So 12 kilometers to 1 hour. Now I know that there's 1,000 meters in 1 kilometer. So I'm going to use a conversion rate of 1,000 meters to 1 kilometer. Here's the thing. Kilometers is on the top of the first fraction, which means it needs to be on the bottom of the next one. So I'm going to write 1,000 meters over 1 kilometer. The reason why I do that is because now these kilometers can cancel out. So I have meters and hours left, which is what I want. So I'll do 12 times 1,000. I'll get 12,000 meters over 1 hour. And I'm done. So the big thing you need to notice is that since kilometers were on the numerator of the first fraction, they went to the denominator of the second. Next, I have 20 cars to 1 minute equals how many cars to 1 hour. So I know that there are 60 minutes in an hour, so that's going to be my conversion factor for this one. So I'm going to start by rewriting the original, 20 cars over 1 minute. I know there's 60 minutes in an hour. Minutes are on the bottom of the first one, so they need to be on the top of the next one. 60 minutes, 1 hour. Because now these minutes can cancel out. So now when I multiply, I get 20 times 60, which is going to be 1,200 cars in 1 hour. All right, looking at the next one, I have 10 centimeters over 1 minute is approximately how many inches over 1 minute. Okay, so if you notice for number 1 and number 2 we had an equal sign because these were exact conversions. 3 and 4 they have approximation signs because we don't know if it's exactly going to be one. So I need to start by rewriting the original. So that's 10 centimeters over 1 minute. And now I need to convert centimeters into inches. So I know from a table in the book that 1 inch goes with 2.4 centimeters. So 1 inch is congruent to 2.4 centimeters. So I have centimeters on the numerator of the first one. So that means centimeters need to be on the denominator of the next one. The 1 inch will go up top. So these centimeters can cancel out. So now I have inches over minutes, which is what I want. So that's 10 inches over 2.54 minutes. Okay. But if you look, it asks me for how many inches per 1 minute. So that means I need to make my denominator 1, which just means I'm going to divide the numerator and the denominator by 2.54. We talked about that earlier. So when I do 10 divided by 2.54, I get 3.94 inches, and then over my 1 minute. So that's approximately my answer. Looking down at number 4, it says 525 feet over 1 minute is approximately how many meters over 1 second. So if you notice, in 1, 2, and 3, we were only changing one of the units. In number 4, we're changing both. Feet are becoming meters, minutes are becoming seconds. So we have to do more steps for this one. We're going to start the same way, though, by just rewriting 525 feet over 1 minute. I'm going to convert minutes first. I know that there are 60 seconds in 1 minute. So minutes on the bottom, so it needs to go to the top. 1 minute is 60 seconds. So right now I can go ahead and cross out the minutes. Now I have feet per second, which isn't quite what I want. I want meters per second, sorry. So I know from my book that there are 0.3048 meters in a foot. So feet are at the top, they need to be at the bottom then, cancel out. 0.3048 meters will go to the top now. So feet can cancel out. So if you look, the units that I have left are seconds and minutes. So I can go ahead and multiply across the top. I do 525 times 0.3048, and that gives me 160.02 meters. On the bottom, I'm just doing 1 times 60 times 60, so I wind up with 60 seconds on the bottom. Now, if you look at the problem though, they want how many meters per 1 second. So that means I need to divide the numerator and the denominator by 60, and I'll get 2.67 meters over 1 second. I'm done there. Again, if you don't know all of those conversion factors, that's fine. They're in the textbook, and you'll be able to use that on your second and your test. So looking at the back side, there's a couple word problems. Number one, I want you to do on your own, because it's pretty easy. It's just one conversion. Number two, I'm going to do with you guys, because it's pretty difficult. So it says a cheetah can run at a rate of 75 miles per hour. About how many meters can the cheetah run in 5 seconds? So I have 75 miles per 1 hour. My goal is to get in meters over 5 seconds. So we've got to get miles turned into meters and hours turned into seconds. So there's a lot going on here. But we start by rewriting our original 75 miles over 1 hour. I'm going to work on the miles to meters first. Now again, you can use your textbook for the conversions. There is no conversion from miles to meters, but there is a conversion from miles to kilometers. So miles is in the numerator, the first one, so it's going to go to the denominator of the second one. 1 mile is equal to 1.609 kilometers, approximately. So I start there. The reason why I do that, miles can cancel out. Now I need to turn kilometers into meters. So kilometers in the numerator, now they need to be in the denominator to cancel out. So meters will be on top. I know that there's 1,000 meters in 1 kilometer. So now kilometers can cancel out. So we've gotten miles turned into meters, so we're halfway there. Now we need to turn hours into seconds. So you can do this in 1 step or 2 steps. I'm going to do it in 2 steps. Hours is in the denominator, so now it needs to be in the numerator. 1 hour is 60 minutes. So hours can cancel out now. Now I need to turn minutes into seconds. Minutes was in the denominator, now it goes in the numerator. I know that 1 minute is 60 seconds. So those minutes cancel out. So now if you look, I have meters and seconds, which is exactly what I want. Okay, so now I can go ahead and multiply. When I do 75 times 1.609 times 1,000, and when I multiply all that together, I get 120,675 meters. That's 75 times 1.609 times 1,000. On the bottom, I'm just doing 60 times 60, which is 3,600 seconds. Now what we want is how many meters can a cheetah run in 5 seconds. So we're going to start by turning this into a unit rate, meaning we want the denominator to be 1. So we're going to divide both of those by 3,600, and we'll get 33.52 meters per 1 second. And then we want to turn this into 5 seconds, so we can just multiply the top by 5, and we'll get 167.6 meters. So that's approximate. So a cheetah can run 167.6 meters in 5 seconds. Now, I know this is a lot of work, but if you follow all the steps, it makes sense. If something's in the numerator, it's got to be in the denominator, get rid of it. If it's in the denominator, it needs to be in the numerator, get rid of it. All right, so try number 1 up here, and then there's some review problems that you need to make sure you do.